This is a screencast on alkenes and alkynes. So this first question says, are these saturated or unsaturated? And the best way to find out is just to draw it out. So I see 1, 2, 3, 4 H's. 1, 2, 3, 4. They at least have single bonds. That last one has 3 H's on the end. That next one has 1 H. That next one has 1 H. And that last one has 3 H's. They all must have 4 bonds. So this one has 4, 1, 2, 3, 4. Now we look at this C, it has 1, 2, 3. It's missing 1. I look at this one, 1, 2, 3. It's missing 1 also. This end one, though, has 1, 2, 3, 4. If I put a double bond in there, then that one has 4 bonds and that one has 4 bonds. And it means it's unsaturated since it has a double bond. And let's name this one, in fact. So it has 1, 2, 3, 4 carbons, which is bute, has a double bond, which is ene, and you count the carbons 1, 2, 3, 4. It starts on the second carbon, so it's 2-butene, or you could say 2-bute, or bute-2-ene. That's so backwards. Let's look at that next one. That next one has 1, 2, 3, 4, 5 across. 1, 2, 3, 4, 5. And on the second one over, it has 1 down. That one has 3 H's. 3 H's, so that one's full. That one's full. That one just has 1 H. That C has no H's. That C has 2 H's. So done, 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 done. Can't put a double bond there, so we must put something there. So 1, 2, 3. It must be a triple bond. 1, 2, 3, 4. Then that one has 1, 2, 3, 4. And let's name this creature. It looks delicious. It's unsaturated because it doesn't have the maximum number of hydrogens. We have to include the triple bond in the longest chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's 5. So it's pentine. I'm going to do the old school way because I like that one the best. And I'm just going to call that one 1. So it would be 1 pentine. I have a methyl group on the 4th carbon, 4 methyl, 1 pentine. Let's look at these other ones. Number 3 is saturated, because there's no double bonds, and 4 is unsaturated because it has that double bond. Let's see if we can name these real quick. This one would be 1 methyl cyclohexane because they're all single bonds. This one, oh boy, I think we have to start counting there. 1, 2, 3, 4, 5 because we have to include the double bond in the direction that we're going. So we have cyclopentene, and that's a 1 cyclopentene, and it's a 1, 2, 3, 4, 4 methyl. I'm just going to write me for methyl, 4 methyl, 1 cyclopentene. Now let's look at these other ones. I think actually we just named this one up there. That was 2-butene. This one is maybe that's a triple bond, but it looks identical. If that's a triple bond, it is 2-butene. Now let's look at 6A. This one, I see a cyclohexadiene, because there's 2 double bonds, and I would call that one 1, 2, 3, 4. So it's a 1, 3 cyclohexadiene. Let's see if we can see this little cramped one down here in the corner. It is a cyclobutadiene because I see 2 double bonds, and I think I would call that one 1, go with the bond that way. 2, 3, 4. So it's 1, 3 cyclobutadiene, and it's a 1 methyl in front of that. It's tough to write backwards, isn't it? Lefties must love this. Let's do a couple more of these. Look at this one. I see a double bond here. It's a cyclopentene. I think I would call that one 1, 2, 3, 4, 5. So it's a 1 cyclopentene. The double bond takes precedence over the branches, so it should be the 1. And that one is an ethyl group. That one's a methyl group. We have to alphabetize, so it'll be 1 ethyl dash, that looks like a 3. That's a 3, isn't it? methyl, 1 cyclopentene. And let's look at B here. It's I'm going to write way up here, cyclohexane. There are no double bonds in there. And we have 3 branches. It doesn't matter which way you count, 1, 2, 3, or 1, 2, 3 the other way. So we have 2 methyl groups, and we have 1 ethyl group. Ethyl has to go first because it's alphabetized, so I would say 2-ethyl dash 1, 3, 1, 3 dash dimethyl cyclohexane. I hope this has helped you name some alkenes and alkynes.